My name is Vishal. We are going to talk about the designing and a centralized patient data repository. I have around 20 years of experience in database technology and currently working with a healthcare company as a data architect. So we are going to talk about that how to design a centralized patient data repository. Nowadays, in large healthcare organization, the patient data is scattered across multiple systems, electronic health records, lab reports, pharmacy reports, and insurance claims. Our task is how to design and implement a centralized data repository that would consolidate all patient information into a single, secure, and easily accessible platform for provider. This is what the today's topic is: designing a centralized patient data repository. Nowadays, the all healthcare has a lot of data, and we have to see how to maintain it. Healthcare organizations worldwide are experiencing a challenge in managing and exchanging patient data across various systems and institutions. The advantage of healthcare technology is introduce new complexity in data management, with modern healthcare facilities generating an average of 665 terabytes of patient data annually through various sources, including diagnostic imaging, clinical documentation, and real-time monitoring devices. The system architecture, when we are going to talk about three things here. Basically, microservice architecture, cloud native approach, and cost efficiency. When we talk about architecture, microservice architecture is evolved significantly to address the growing complexity of modern data management analysis. Analysis of public healthcare institution has shown that implementing a microservices-based architecture with distributed storage capabilities can improve system performance by up to 45% compared to traditional monolithic approaches. A comprehensive study of public hospitals revealed that organizations adopting cloud-native architecture experience a 38% reductions in operational cost and 52% improvement in data accessibility. The economic impact of improved healthcare interoperability has been substantial. Healthcare organizations that have been successfully implemented comprehensive interoperability solutions have observed an average cost saving of $3.7 million annually through reduced duplicate testing, improved resource allocation, and enhanced operational efficiency. When we talk about the cloud native approach or the cost efficiency, health organizations adopting our cloud native architecture have experienced a 38% reductions in operational cost and a 52% improvement in patient data accessibility across department. Our specializing cloud-based archival system reduce storage cost by 63% while maintaining a rapid retrieval times under 200 milliseconds for frequent access patient retrieving data. The core component is the data storage and integration. Data storage layer and integration layer. Once we talk about the data storage layer, basically represents the cornerstone of healthcare information system, requiring careful consideration of data type, access patterns, and compliance requirement. Research conducted across multiple public hospitals demonstrate that PostgreSQL implementation for structured clinical data achieved 99.99% uptime while managing an average of 7.8 million patient records. The study reveals that facilities utilizing MongoDB for unstructured data can also improve the time. The cloud-based system reduced storage cost by 63% while maintaining several retrieval times under 200 milliseconds. That is what going on because it's a huge amount of data. If you talk about, or the same thing, if you talk about the integration layer, FHIR gateway implementation, reduce integration complexity by 56% and improve data consistency by 71%. Integration layer is basically serve as a critical middleware component, facilitating seamless data exchange between disparate healthcare systems. Research analyzing FHIR API gateways implementations across public hospitals indicate that centralized API approaches reduced integration complexity by 56% and improve data consistency by 71%. The HL7 message processor component demonstrate the capability to handle 850,000 clinical messages daily with a 99.95% successful processing rate. ETL pipeline implementations in public healthcare environment have shown remarkable efficiency in data transformation and loading. According to recent studies, modern ETL system can process up to 350 GB of clinical data per hour while maintaining data quality scores above 95%. The real-time event bus architecture has proven particularly effective in managing clinical workflows, processing an average of 12,000 events per second with latency under 100 milliseconds, enabling real-time clinical decision support system. The security layer. If we think about security layer, comprehensive IAM system reduce unauthorized access attempt by 97% while processing an average of 500,000 authentication requests daily. RBAC combined with ABAC has shown to reduce security incident by 82%. RBAC means role-based access control and ABAC means attribute-based access control. Analysis of public hospital implementation revealed that comprehensive IAM systems reduce unauthorized access attempt by 97% while processing an average of 500,000 authentication requests daily. Encryption service utilizing industry standard protocols have demonstrated robust protections for sensitive health information. Research indicates that modern encryption implementation in healthcare settings can secure up to 35 terabytes of patient data daily while maintaining processing overhead below 3%. Once we talk about how to design data model for healthcare system, designing data model of healthcare system, we can talk about patient-centric schema, FHIR compliant structure, flexible storage approaches, and versioning and audit control. Patient-centric schema, modern healthcare information system requires sophisticated data modeling approach to handle the increasing complexity of patient data. Research analyzing healthcare data architecture has demonstrated the implementation of FHIR compliance schemas with optimizing index strategy can reduce query response time by 35% while maintaining data integrity across distributed system. A study of healthcare facilities revealed that properly structured patient-centric schema can handle up to 2,500 concurrent transactions per second while maintaining response time under 100 milliseconds. Data duplication strategy, we talk about deterministic matching approach and we talk about probabilistic matching approach. Deterministic matching and probabilistic matching. Deterministic matching, like combining out text identifier matching, and probabilistic is basically we talk about machine learning based approach. Healthcare organizations face significant challenge in maintaining accurate patient identify across multiple systems. Research indicate in deterministic matching algorithm has shown that combining traditional identifier matching with advanced correlation techniques can achieve accuracy rate up to 97.8% in identifying duplicate records. The study of 15 healthcare institutions demonstrate that implementing multi-factor deterministic matching reduce false positive rate to 0.03% while processing approximately 600,000 records comparison per hour. The effectiveness of deterministic matching significantly improved when incorporating temporal data analysis. What exactly temporal data analysis? Analyzing historical pattern alongside by accuracy of 24%. Once we talk about probabilistic matching implementation, the advanced probabilistic matching techniques have emerged as a crucial component in modern healthcare data management. Analysis of machine learning based systems has demonstrated accuracy improvement of up to 28% compared to traditional deterministic methods, particularly when dealing with incomplete or inconsistent data. Research across multiple healthcare networks has shown that sophisticated probabilistic algorithm can achieve a match rate of 92.4% even with particularly complete demographic data. Once we talk about how to FHIR API layer implementation. This is basically, you can see the numbers, 42% of integration simplification, 31% data accuracy, 89% security enhancement, 850K daily API request. How it manages a lot of data. The implementation of FHIR-based interoperability solutions has demonstrated significant impact on healthcare data exchange efficiency. Analysis of healthcare organization has shown that FHIR R4 implementation can reduce data integration complexity by up to 42% while improving data accuracy by 31% compared to the legacy systems. The adoption of a smart on FHIR authorization framework has revolutionized secure healthcare data access. Studies indicate that implementing comprehensive FHIR-based security protocol reduce unauthorized access attempt by 89% while processing authentication requests with an average latency of 180 milliseconds. Data accuracy, daily API request, and security enhancement. You can see the numbers how it match. When we talk about real-time synchronization architecture, we talk about change data capture, that is also called as CDC, event publication, data synchronization, and conflict resolutions. CDC, the implementation of change data capture mechanism in healthcare environment has shown remarkable improvement in data consistency maintenance. Research demonstrates that modern CDC systems can effectively process approximate 500 changes per second during peak operational hours, with average end-to-end latency remaining under 150 milliseconds. Healthcare facilities implementing CDC architecture have reported a 57% reduction in data synchronization errors and a 43% improvement in real-time data availability. Event publication system integrated with MassSQ had demonstrated robust performance improvement. Conflict resolution mechanism, modern healthcare data system requires sophisticated conflict resolution strategy to maintain data integrity across distributed environment. Our research indicates that implementing a version-based, vector-based conflict resolution mechanism can successfully handle up to 750 concurrent updates per second while maintaining data consistency across distributed healthcare network. Event publications and data synchronization is also two major parts when talking about real-time synchronization architecture, how it behaves. Data protections, measures, encryption implementations, they all are a part of this, our whole architecture. Security and compliance in healthcare system, data protection, encryption implementation, access control system, and audit trail implementation. If we talk about data protection first, when we talk about data protection measures, the security landscape in healthcare information system has evolved significantly with the increasing digitalization of patient records. Analysis of healthcare security incident has revealed that approximately 63% of data breaches occur due to unauthorized access, while 27% result from system vulnerabilities. Research indicates that healthcare organizations implementing comprehensive security framework experience a 71% reduction in successful breach attempt, with modern encryption strategy showing particular effectiveness in protecting sensitive patient data. Encryption implementation. Encryption implementation, we can say we are implementing AES-256 encryption for data at rest had demonstrated 99.98% success rate in preventing unauthorized data access with performance overhead averaging only 3.2% compared to unencrypted system. So healthcare organization must maintain robust encryption mechanism to protect patient data throughout its life cycle. Studies of healthcare facilities implementing standard encryption protocols shows that modern system can process up to 500,000 encrypted transactions daily while maintaining response time under 150 milliseconds. We are implementing AES-256. Research across multiple healthcare institutions has shown that TLS 1.3 implementation for data in transit can effectively secure network communication while adding only 38 milliseconds of average latency. Organization implementing field-level encryption report the ability to protect sensitive data element with 99.99% reliability while maintaining database query performance within 94% of baseline measurement. Access control system. Modern health environment requires sophisticated access control mechanism to ensure appropriate data access. Role-based access control system successfully manage an average of 15,000 unique role across distributed network with authorization decision processed under 85 milliseconds. The integration of attribute-based access control has shown a 76% improvement in access precision compared to the traditional RBAC-only implementation. Emergency access procedures have become increasingly crucial in healthcare environment. Research demonstrates that properly implemented break glass procedure can provide emergency access to critical patient data within 30 seconds while maintaining robust security protocol. Audit trail implementation. Comprehensive audit trail forms a clinical component of healthcare security infrastructure. Studies indicate that modern healthcare systems generate between 4.2 and 5.8 million audit. Tamper evident logging mechanism ensure complete traceability of all data access and modification. Organizations implementing blockchain-based audit trail report 100% success rate in maintaining audit log integrity across more than 1.8 billion logged events over a typical 6 months period. Once we talk about the performance optimization in healthcare systems, it is again go with the query performance, advanced indexing, caching systems, and horizontal scaling. Query optimization strategy, the optimization of query performance in healthcare record EHR system has become increasingly crucial in health organization manage growing data volumes. Research analyzed query pattern in large-scale EHR implementing has shown optimized database engines can reduce an average query response time by 64% while supporting concurrent access from multiple clinical applications. A system processes up to 15,000 clinical queries per second while maintaining average response time under 150 milliseconds. We should advance indexing implementation, the very important part. It reduces the query execution time by 74% for complex database joins. Implementation of a strategic indexing approach has demonstrated significant impact. Analysis shows that healthcare database utilizing composite index for frequently accessed clinical data path reduce query execution times by average 21% for complex joins involving patient records and clinical observation. Healthcare organization reports that implementing partial indexes for filtered query result in 38% reduction in storage requirements. Text search optimization has emerged as a critical requirement for managing unstructured clinical documentation. The response time from 1.8 seconds to 324 milliseconds. Healthcare facility utilizing optimizing text indexing strategy report the ability to process up to 750,000 clinical notices daily while maintaining consistent sub-second response time. The caching system architecture, modern EHR system requires sophisticated caching mechanism. 450,000 requests per second, wide latency under 5 milliseconds. Caching consistency management through right-through policies has shown particular effectiveness in healthcare environment. Research demonstrates that EHR system implementing a right-through caching maintain 99.95% data consistency while processing an average of 8,000 write operations per second. The scalability strategy is basically horizontal scaling and load management. Once we talk about horizontal scaling implement has demonstrated significant improvement in system capability. Research indicate that patient ID-based SADing enables EHR system to effectively manage data up to 2.5 million active patients while maintaining query response time under 200 milliseconds. Auto-scaling mechanism based on clinical workflow patterns have proven particularly effective in healthcare environment. Once we talk about implement consideration for healthcare system, cloud infrastructure for healthcare systems. If you see here, we can see infrastructure cost, deployment time, resource utilization, compute cost reduction, storage cost reduction, and security incident improvement. Monitoring and operations is a very important part that how healthcare matrices, database monitoring, alerting system, and compliance monitoring will help. Health matrix Implementation. Effective monitoring system plays a crucial role in maintaining healthcare system reliability. The comprehensive application performance monitoring reduce mean time to detection by 62% compared to the traditional monitoring approaches. Healthcare organization implementing detailed performance monitoring capture approximately 6.2 million matrices daily. Database monitoring has become increasingly sophisticated in healthcare environment. Research shows that organizations implementing comprehensive database monitoring identify potential performance issues an average of 32 minutes before user impact with 91% accuracy in problem identification. Alerting system configuration in the modern healthcare environment requires robust alerting mechanism to maintain system reliability. Analysis indicate that organizations implementing a multi-level alert system reduce mean time to resolution by 58% while maintaining a false positive rate below 3%. The study shows that properly configured alerting system successfully identify 95% of critical issues within 45 seconds of occurrence. The implementation of compliance monitoring alert has become essential for maintaining regularity. Once we talk about the final words, if I want to say here, in the today's as a conclusion, the implementation of centralized patient data repositories represents a complex but essential undertaking for modern health organization. The success of such system relies on the careful integration of multiple components, from robust data governance policies to comprehensive security measures and continuous monitoring protocols. By adopting a standardized framework like FHIR and implementing sophisticated security controls, organizations can create systems that effectively balance data accessibility with regularity compliances. The ongoing evolution of healthcare technology necessitates a commitment to continuous regular security assessment and strong partnership with healthcare providers. The effective implementation of the system ultimately leads to improved patient care outcomes, enhanced operational efficiency, and better healthcare service delivery through seamless data exchange and access capabilities. Thank you so much.